The goal for this project was to create a machine learning agent capable of cooperative behavior and pattern recognition for the use within a social deduction game. With the use of the ML Agents framework, I was able to construct several environments and use complex reward and observation structures to mold behaviors using reinforcement learning. Throughout the development process, the project idea was adjusted to work alongside the limitations of the framework, while still working to provide a solid proof of concept for the required components of a social deduction agent, the first being cooperative behavior. The gate puzzle environment is a simple button puzzle that requires 3 players to complete. To get past a gate, a button must be pressed to remove it, but in doing so will remove that agent from the scene. 2 gates must be opened and 2 agents sacrificed for the final agent to complete the game. With the use of the MAPOCA trainer, agents can be provided with individual and group rewards, allowing them to be encouraged to work towards a common goal, regardless of the consequences of their decisions. In this example, the agent group is provided with a small reward for pressing a button and advancing the game, encouraging team-based behavior. A large reward is given for completing the game, and a small time step penalty is given to encourage faster problem solving. With this in place, you can see the agents understand the requirements and work together to complete the goal. Cooperative agents all work from the same brain, but a singular agent is never given a specific role. It's not always the same agent that presses each button, showing that the neural network can adapt to the scenario and isn't completely reliant on repeat patterns. This is important for a social deduction AI, as adapting to a changing environment makes the game more fun to play. The second environment exhibits the pattern recognition skills required to make reasonable decisions. In this example, 4 agents are placed in the scene, 3 of them are NavMesh agents and 1 is a reinforcement learning agent trained with jerky movement. The decider agent will observe the 4 agent positions and attempt to choose the jerky agent after 30 seconds. The results show a 65% correct guess accuracy, and whilst this is not perfect, it can be assumed that with more training time and a more complex observation and reward structure, the accuracy could be increased. However, it's important to consider for fair play that an AI opponent isn't always correct, and a lower accuracy could be considered as a perk to aid player empowerment. These 2 behaviors working together would form a strong foundation for a machine learning application in social deduction games that typically don't use AI due to the game's complexity. This could be an important step forward in the advancement of game AI in the future.